Okay, so we're going to go over 1.5. We're still on the matching kind of activity. So we're going to work on A7. And if you remember the directions for this, it was like looking at this, come up with another representation of this, and then find the inverse of this from your B cards. Your B cards are down here, right? And so we've already matched a couple of them. Sorry, I don't want to make you too dizzy, but we've already matched a couple of them. So the very first thing that I want to do is I want to look at this thing and I want to look for I want to look for a different representation. So one of the representations that I can definitely use, close that, is by graphing these and looking at those points. So I will start with that. So then let's go to Desmos. And then the way you enter this is you could either enter it as a table. I don't know if I've ever shown you how to enter a table. You just go like this, you hit plus, and then you have a table. And then you just enter these points exactly as you see them. So I'm going to enter those really quick. So -5, -3, -1. If you notice, it's already thinking about what my next numbers are without me doing that because it's following the pattern, right? 1, 3, 5. Okay. Here, I am going to go with -125, -27, -1, 1, 27, and 125. And so I just entered that table. You can enter these as individual points if you want. You can do that. However you do it, I just wanted to see a picture of this. I already kind of have a picture because it's negative, and then it's negative, and then it's positive. So it's like this negative action here. So this looks like it's only 2 dots, but these numbers are quite big. So I'm going to zoom out a little, and I'm looking for more of my little dots. Oh, there's some more right there and there. And then if I zoom out even more, there's my last dot, but that's too much of a thing and I don't want to look at that really. So I see that there's this like curve. Do you guys all see this curve? You should remember this curve. If you do remember him, he's a cubic. He's a cubic. So this is going to look like something x cubed ish. I don't know if that's exactly it, but the cube, this is supposed to look like a 3 right here. This is reminding me of cubes. This curve right here that looks like this, looks like a little, I don't know, some people say snake. So I don't know exactly. So I'm going to play around with my y equals and see if that actually works. So y equals x to the 3rd. And I'm like, boom, look at it, hit all of those dots, dot, 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 right? And I drag it all the way up here to 125 line. Look, it goes through there. I actually found it. Miss Johnson, but what if we didn't know it was x cubed? No problem. You actually don't need this right now. I'm just talking out loud to you so that you remember this. So I'm going to graph this little guy over here. And I think I was using like blue to show you mine, and then orange to show you the f of x. I'm going to draw this. Again, not going to look the best, but that's all right. It just kind of looks like this curve like this. Okay. So then if you think about this, right, I want this to be reflected. For those of you who are very visual learners, I want this to be reflected across the y equals x axis. So as you can see, if this thing goes this way up here, when I reflect it, it's going to go this way down here, right? You guys will see this here. Let me annotate on Zoom. How great I draw on Zoom is so fantastic, right? So here, and it'll continue out this way, right? And this guy down here, when it's reflected across this line here, will look something like this-ish. So do you see how the snake went from tall and skinny to short and fat? Okay, don't worry, they're not offended by these terms, their functions, they're okay. Okay, so then I will draw that here for myself. So here, I want to change this to orange, and I'm going to kind of draw it like, I don't know, something like that-ish, right? So that's the first thing that I'm looking for. I'm looking for a curve that looks like that. I'm also looking for a table that if I inverse this, You guys use the word swap or switch or flip-flop, whatever the case might be. Let me clear my little drawing out the way there. Okay, so now I'm looking for B to look like those things. I'm going to stretch this guy out a little, maybe right here, right? So let's see, B, who do I, no, 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 oh, no, that's negative 216 and that's negative, no, that's a no, that's a no. No, because that's supposed, no, see, it's supposed to be 28 and 5. No, not that. Let's see, that one's a no. That's no, because like, look, I'm supposed to get -1, -2. No, because if this is -1, this is supposed to be -2, and no, that doesn't work. That one's a no. This one's a no. And this one says the function is continuous and grows an equal factor of 5. 5, there's no 5 in my function. So wait, I must have missed something. Hold on a second, let's go back. So it's not going to be log base 3 of x, right? Right, and then you could check too if you're like, Ms. Johnson, I don't know, maybe it is. So let's take this function really quick and graph it. I already graphed it. This is kind of, or this is yeah, anyways, I'll just graph it, be quiet. So I'm going to try plugging in this log base 3 of x to see if that works. So I go log, remember your bases are over here in A, B, C, and then right here. So I get a 3 and then I pop it back up and it's x. That curve does not look like my orange curve, right? That curve does not look like my orange curve. And plus when I plug in -125, which is this guy all the way over here, he doesn't even exist on the left-hand side, right? So yeah, that's not going to be it. This one's not it either because, right, like it looks, there's 2 parts to this function, so that's still a no. This one we already found. This is -216. Oh, wait a second. Wait a second. I wonder if because these numbers don't match. Hold on. Let's look. So I'm going to take me back over to my graph because those numbers didn't match those numbers. So let me take this over to my graph. Now, notice I'm going to flip-flop these because this is the inverse and this is the function. I'm going to plug some numbers into my table down here. And if you notice, Ms. Johnson, why are you switching it? I'm switching it because this is the inverse and this is the function. And you know that when I flip-flop these, I need to switch these. Okay, so I gotta go -6 and -216. And I want to see where this point is. Wait, that one's too far off the graph. Let me choose a couple back over here. Let's go 0, 0. And then I need to take this guy out. So I'm just looking at these. Oh, look, 0, 0 is on that curve right there. He's right there. Oh, that looks pretty good. Okay, let me try this one, -8 and -2. So -2 and -8, as well as 2 and 8. And then let me zoom out of, oh yeah, look at it's right there. And then put this guy away. And then, oh yeah, he's right there. So this was it. And it tricked me. Oh, you tricked me, Miss Johnson. And the reason why it tricked me was because none of these values here flip-flopped to this over here. So maybe some of you guys saw that and were like, hey, Miss Johnson, it's right there, right? But I kind of like to do the thing where I am a student and I'm like looking for exactly what I want to see. And if I don't see it, then I need to go back and check. So B4 does match with A7. B4 does match with A7. Feels like we're playing, what you call it? What is that called? Bingo. Okay, so let me update my chart up here and I will write it in. My chart is supposed to be catching up. Oh, that's why. Okay, give me a second. B4 and A7. Oh, I'll just write it here. I go bigger. So this is B4. And that's because, why is that? Why were they, what helps me understand that? Go 15, so it's a little bigger. Highlight, okay. So B4 and A7 matched because the tables were swapped. Oh, tables had values that were swapped. And then I graphed it. I graphed the function on Desmos and checked both tables, right? So I'm going to extend this out just so that it doesn't get in the way of my other little guy. That's fine for now. Okay. Hopefully that helps you understand a little bit of it, right? So there goes B4 and A7. We had a couple others that we put up there as well, so we'll catch that up later. So now do we understand slide 9? Is that okay? That one was tricky because they didn't give you the same values, right? They gave you different values for that. The next one someone asked for was 11. And it's this guy. And I'm like, wait. I saw this guy. I just saw this guy, right? A little bit ago when I had my Desmos up, right? And he was that log. So let me turn these guys off really quick. And this guy, yeah. So this guy kind of looks like this guy, right? So it's a log. It's a log, except for this one has 5,1, and this one says 3,1. How can I adjust this so that it matches this one exactly? How could I just adjust this so it matches this one exactly? So, so my brain is saying, just so that you're following me with my thoughts, this looks like a log equation, looks like a log function. Okay, it looks like a log function, but how would I adjust this function here? So because this point right here is at the point 5,1, and that's not what this one says. 5,1 would be right here, but this one has a 5,1 is right here, 3,1 instead. So how would I adjust this? Anybody have any clues on how would I adjust this? How would I adjust this function? This is for your participation points. Come on, y'all. How would you adjust it? Yeah, exactly. So look at what Alyssa said in the chat. Awesome, Alyssa. Thank you. So yeah, this would be a base of 5. I don't know if she's right. I mean, I do actually know that she's right, but like as a student, you're like, I don't know if she's right. So you would just change this base to a 5, and then hopefully you get, oh yeah, I did, look, 5,1, right? So then I'm thinking, okay, well, man, I remember Miss Johnson telling me what the inverse of this function would be. What would the inverse of this function be? What would the inverse of this function be? So let me just look through all my little B pages here. So close your eyes if you get a little dizzy from me scrolling. Right, so let me scooch you over. Like, scooch this over. Let me see what you're doing here. Okay, so I'm looking for, right, because if I turn this over, it's going to look like this, right? It looks like something like that. Oops, that should have been orange. So I'm looking for that. So the log isn't the inverse of a log. The log isn't an inverse of a log. But here, Ms. Johnson wrote me a note, and I did this, I think in office hours. So it says inverse of log is an exponential. Oh, that helps me. If the inverse of a log is an exponential, that means for this one here, I would just write this as an exponential, right? So you want me to write this as an exponential? Yes. So let me see. Let's get back to this guy right here. So write it as an exponential? Yeah. So something to the x. Yes. What would your base be? In this case, what should your base be of your exponent? What should your base be for your exponential? In the chat. Yes, exactly. Someone else say it. And if you don't know, ask. If you don't know, get it in there. Get it in your head. Someone else tell me. Besides, I have one person. I have 2 people. what would the base be? I have 2 people. Come on, y'all. This is your, just guess. What would your base be? Yes, exactly. My base would be 5. Jonathan, why would my base be 5? Because that base is 5. The way you say this is log base 5 of x. So my base is 5, Miss Johnson. Yeah. 5 to the x, Miss Johnson. I don't know. Let's try it. So does that look like a mirror of that? Does that look like a mirror of that? And you're like, yeah, Miss Johnson, you're right. It is. Yes. Okay. So then you're excited because then now all you have to do is look for that thing, right? Okay. So we go here. No, no. We already know who you belong to. We already know who this one belongs to too. That doesn't look like the mirror image of that. 0,3. No, because that's 1, 0. So that has to be 0, 1. So this is a no. That one's a no. 0, 1. Oh, 0, 1. Wait, -2, -3. No, because -2, it needs to get closer. So no. Do you guys understand what I'm saying by no? So this 0, 1 matches, and I'm like, yes, look, it matches. It's right here. But this next point right here, let's see, -2, -3. If you look over here, this gets closer. Remember, this is called an asymptote. It gets closer to the x-axis. That's a horrible drawing, but just pretend. So -2 is actually closer to the x-axis than it is right here. So that's a no. So close, but no, right? This one's a no, because that doesn't even look like that. So no. And then this one says words, and I'm like, oh, it has to be this one. It says the function is continuous. Is that continuous? Yes. And grows by an equal factor of 5. Ooh, that's that 5, right? That's that 5 that shows up here. Oh, that 5, right? That 5, is that 5? I don't know. Let's see. And the y-intercept is 0, 1. Wait, this guy's intercept is 0. Ooh, look, it's 0, 1. So B10 looks really, really close to it, but I'm not sure about this whole business of factor of 5. So if you remember what a factor of 5 is, the word factor comes from like either multiplying or dividing. Like if I said, let's see, what's a good thing? Your money, right, is increasing by a factor of 2. That literally means, I don't know, whatever, every single week, every single month, every single year, whatever, it's doubling, timesing by 2, right? And if you look at this factor here, this is really multiplying by 5 at every single point, right? It's multiplying by 5 at every single point. So if you look at these, a couple of these numbers, just to prove to you what I'm talking about, the first number that I get to is 0, 1. The next number I get to is, sorry, it's hard for me to grab this with my big old mouse. It's going to be 1. And then if you plug in 1, it's 5. So notice here, you go from 1 to 5. And the next guy I should get to is probably 25. So I'm looking, yeah, doesn't that look like it crosses at 25? Yes. So the answer for that one that we were just on, let's find him. So B10 was this guy. B10 is A9. B10 is A9. Let me go up here. And let's just copy this guy here to B10. What did I say? A9? I think I said A9. That makes sense. Let's get this out a lot. So this is B10. Ms. Johnson, how did you get B10 again? Well, it went back to the Desmos. Where did my Desmos go? Here. I went back to Desmos and I looked at this and I was like, oh my gosh, I know you. You are log, right? If you don't know that this is a log, just kind of get familiar with it, right? This is like, I don't know, when you were younger and you called everything a dog because you had a dog, and then you saw this other little animal that looks kind of like this with big eyes and whiskers, and you're like, oh, that's a dog. And you're like, no, no. Mom's like, no, 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 that's a cat. And you're like, no, it's a dog. It's a dog. And so then you realize later, oh, dogs look like this and cats look like this. So get in your head that this is what a log looks like. This is what logs look like, right? And then get in your head that the inverse, where did I write that? Right here. The inverse of a log is an exponential. So there's levels to this. And this is what I want. This is where, you know, when I encourage you like this, like you don't need to understand everything. You just need to understand whatever level you're at and then push yourself to the, you know, the one level outside of you. So if you didn't know that this was a log, that's your job for today. That's a log. That's a log picture, right? If you didn't know this was a cat, don't judge me on my great drawings, right? Now you know it's a cat. Here's my log. Right? These are logs. If you know that this is a log, now I want in your brain, oh, the inverse of a log is an exponential. And that helps you understand this part. That's the way I was able to grab that none of these matched as the inverse except for this one. Okay, so go ahead and write that up however you want to explain that here. I knew it was a log. Then I knew that that the inverse of a log is an exponential. Okay, so yeah, you may not know how to do every single part of this yet, right? Just make sure that you're okay with that. So again, let's go back over here just to make sure that we got this part. When we were over here in this one, we used the fact that we knew that I could flip-flop my table to find it, right? Some of you are like, oh, but Ms. Johnson, you recognize that this was x cubed. But did you notice that I never used this idea here to actually figure that out, right? Okay, so our next slide says Yasmin started a savings account with $5. At the end of the week, she added 3. This function models the amount in the account for a given week. So Yasmin started with 5. At the end of the week, she added 3. So then she had 8. At the end of the week, she had 8. Okay. So you want me to find the inverse of this? Yes. Okay. So I'm going to go through my little B cards here. Okay, so B cards. That doesn't look like that. That looks like logs. There's no 2/3 and there's no 2's here, so that's a no. This one we already matched. This one we already matched. Let's see. This one, no, that doesn't look like that because I don't, you know what I mean? Like at some point she has, I don't know, negative. I don't know. That doesn't make sense to me. So here, if I flip flop these, I don't even see my 8. I don't even see my 8 here. I don't see my $5. I don't see my $3. I don't see anything. So that's probably a no. This one's pretty interesting, but we already found his match, right? But even if I flip flop this, right, this is a, let's see, -2,5. There's that 5. But what does it mean to be at 5 weeks? Then see, that doesn't make sense to me. So this one, that doesn't make sense to me either because we have like no 3 or no 5. And then here, this one's pretty interesting, right? It says Yasmin started a savings account and wait, did I read this wrong? At the end of each week. Oh, at the end of each week, she added 3. Okay, so this point right here is the point 1,8, not it in of itself. And then because she started with 5, that means it's 0,5, right? In the very beginning, we say starting at starting point, 0 time has passed, right? She had $5. After 1 week has passed, she had $8. At 2 weeks, she had $11 or something like that. So I'm just looking for some function that looks like this, okay? So it's not going to be V10. It might be this one. Actually, that one actually makes sense because look, you have 0,5 here. And if you look here, it's 5,0. So far, this one's looking pretty, I don't know why I keep flipping back. This one's looking pretty promising because my 0,5 mirrors my 5,0, right? Let me see this next point though. 1,8 should now be 8,1. And if I zoom in with my eyeballs, this 8,1 looks pretty good. Let me text one more time. So this is 8,1. Let me look for 11,2. 11. Yeah, that looks good. 11,2. So this one here, the word problems always kind of challenge us to translate from English to math. And because, did you see how I read it wrong first, or I didn't pay attention to details of each week? I still got some information, but I didn't get all of it. So then I read it back and I was like, oh, each week she adds 3, right? And so this is that linear function. So how I got this 8 right here, really good question, is so after 1 week, it says that she adds $3 to it. So she adds, meaning she starts with her 5 and then she added 3. So that gave me my 8. So that means this point right here means after 1 week, she has $8 in there, right? Yeah. Very good. Good. Okay. So then I am going to match B9 with whatever card that was. Shoot, A10. B9. What did I just say? B9. Okay, Miss Johnson. B9, A10. B9, A10. Someone say bingo. Uh-oh. B9, A10. Is that what I said? I think I said that. All right, let me put B9 here. And then so here, your justification has a couple of things. There's a couple of things. My justification, I really just looked at the points and I flipped my points. So I swapped my coordinates to check my inverse, something like that. Now, people would have done this differently, right? Another way that you could have done this, okay, close your eyes if you get dizzy on scrolling. I get dizzy. Here we go. Here, some people understand this as instead of looking at this as, so this one here, if I was to graph this, looks like this. You start at 5 and then you increase by 3, right? This one is, sorry, this is time, or actually weeks, whatever. And this is money, right? It's not an 8, that's a $sign. We don't know how to draw. Okay, this here, if you were to do the same thing, this is dollars versus time. Because remember, whenever you're doing an inverse, you're swapping X and Y. So instead of the time being here on X-axis, now the time is up here. Does that make sense? Okay, I'm going to pause really quick. Oh, what I want you to do right now is I want you to go to slide 19 and start thinking about how you would answer this one. Just pause the video real quick. Okay, so if I was to give this question to you on as a quiz question, right? Like as a short quiz question, right? So you're thinking, this guy looks like he's cut off. Yes, he is cut off, right? He doesn't continue like that other one where it was getting closer and closer to the asymptote. He's getting closer and closer to an asymptote. It's like he's literally cut off. So that makes me like, oh, I wonder what that guy is. Okay, so whenever you're looking at different parts of a graph, that's what I want you to think, like, like, why does he look different like that? Or this one right here, like, that one looks funny. Like, it's like 2 functions in one, right? Okay, this one. So first of all, let me just look for, what is it called? A reflection of this graph, right? So that's the first thing I'm looking for. So no, because we already found you. No, because we already found you. Maybe, right? Maybe to this one, but I'm just looking at graphs first. So I'm going to ignore the tables. So definitely not a mirror, definitely not a mirror. And there's no more mirrors here. Okay. So now I want to look at, okay, well, let me check tables. Okay. Because this down here was already completed. I already matched you and I'm really confident. This is definitely not it. This one, let me see. So this one has the point -3, -2. So I'm going to write that point right here. -3, -2, right? So that means that his reflection over here needs to be -2, -3. And I'm like, oh, look, that's it. That's cool. That's it. But wait. I'm not trusting this whole thing. So let me check one more time. So over here, I'm going to do again. I'm going to do another point. There's another good point right here, which is -2, -1. So -2, -1. And I check over here. I'm like, oh yeah, look. It looks really good. Okay, well, if that's the case, then I should look at the point, like, let's just say 6, 1. So I skipped 1, 0 because it's there. But let me check 6, 1. So 6, it is. So these two actually match, right? A4 and B8. I think that's B8. A4 and B8 because I looked at specific points on the graph. And then I flopped them, I flipped them, I swapped them, whatever you want to call it, right? And then I did it, right? So here, what I'm doing is I'm just looking for places. So far, what I've found is I really like tables. I like to flip tables because they're flippable. They're very easy, except for that one that tricked me, right? This one kind of tricked me. Because they didn't show the same values. But here I'm looking at the graph and finding those really good points, right? And then flipping those, and then I matched it with the table. So A4 does match with B8. I will write that up here. A4, B8, A4, B8, A4, B8, A4, B8. A4, B8. Sorry, I was gonna forget, and I don't want to forget. So then how did I do that? I basically looked at the points on the graph and then swapped them. Not swapped them, swapped them. Swap them. Okay. And then matched it with the table values. Okay. So for that one, like I'm kind of hoping, like if you kind of look at my trend, if you're looking at the trends, I kind of like tables. I like graphs. I like functions that are recognizable, like this y equals 3 to the x, right? I like those because I know what the inverse of that is, right? The inverse of 3 to the x is going to be that log. Where is that log? Where did I find you? Down here, right? So I like certain things. I like equations. I like, but not these equations. These equations are a little funky, right? But I like tables because I can flip them and flop them. This one was an interesting one as well. Okay, so going back to Desmos, which is the ready for more question, and I'll post it right here. Right here. So let me make this a tad bit bigger so you're not squeezing into your screen. Create your own set of cards. No, that wasn't the question. Sorry. Where was that one question? Wait, I'm so confused. Hold on a second. Let me find my slide 19 really quick. So slide 19 said something like, oh, it was your exit ticket. So if f of x is given as an equation and g of x is given as a table, I could tell if they were inverses by what? Okay, if you were given an equation and then you're given a table, what's your best guess for that? Can you guys tell me that in the chat? What's your best strategy for if f is given in an equation and g is given in a table? What's your strategy for that? So I'll wait for your guys' responses. All right, so I got a couple of answers. Someone said graph the table and the equation. That's a really good strategy. I like that because then you would see if they were mirrored. Very good. So now that you know how to graph a table on Desmos, that is definitely a strategy. Someone else said inverse the table. Sorry, I'm reading at the same time. Inverse the table and check the graph. Ooh, I like that. So you're saying inverse the table, so swap the values, and then you would check that on the graph. That's good. So someone else said graph the table and the equation. Very good. Someone said graph them both in Desmos. That's really strong. I agree. Finding the values. Okay, so this is interesting. So someone said finding the values and then flipping them. So when you say that, I'm going to make a couple of assumptions. So if I'm wrong, just say, shut up, Ms. Johnson, you're wrong. So when this person says finding the values, I actually like this a lot. So let me tell you what I think this person is saying. This person, I think, is saying, Ms. Johnson, I think that you should, let me get to an equation really quick. I think that you should grab an equation, find an equation, Miss Johnson. Here, grab this equation, right? Find some values on this equation. So she's saying, make a table of values from my equation. That's what I assume that she's saying. Okay, so once you have a table, boom, 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 then you can flip those values and compare the tables. I like that way. So I'm gonna post this one. Let me snip really quick. I'll snip it later. Very, very good. I actually like that way. That was what I was thinking. You don't have to think like me. No worries, no worries. Okay, someone said maybe graphing the equation, done. Looking at the points on the graph and comparing them to the table. Exactly. So graphing them, looking at the points and then swapping them for the table. Very good. I like that way too. Someone else said, or you could tell by inverting the equation and then graphing it. Ooh, I like this way too, right? Someone says, Ms. Johnson, well, you've taught us what an inverse is. We just find the inverse by undoing all of the things, right? And then you can graph it and then you can play with that. Someone said, switch X and Y on the table and then graph those points. Very good. And then see if the graph of the equation matches the swapped X and Y's. I like that too. Very good. I'm sorry, I'm marking stuff down as I'm talking because these are good. Someone else said plugging a number into the equation for the table, like 8.5. Yes, that's what I would actually do. So my favorite way, I will just tell you, is taking an equation. Whenever I'm comparing a table and an equation, like pretend I'm comparing this to this, I'm going to make this guy a table. So I would literally go something like, I don't know, I can't draw right now, but hurry up, Ms. Johnson, just draw it real quick. I would make oh no, that's not what I wanted. That's all right. So I'd make a table and then I compare the values on one side to the flopped of the other. So I'm plugging X in and I get 1 in and it's 3, and I plug in 2 and I get 9, and I'm looking for the swapped values here, right? And maybe I even plug in one of these values here. So I plug in this Y here, 0. So when I plug in it into the X, because remember you swap it, I should get out 0, but I don't. So obviously, no, this is not it. So lots of really strong ways here. Like every single person, you should be proud of what you said, and putting it into the big chat would have been awesome. I know you guys are still getting used to that, but that's okay. So taking any of those ways. So what you're telling me is you're getting more and more comfortable with dealing with different representations, right? And that's what you were supposed to get out of this. Okay. The next question I was supposed, okay, and that was it. So I'm going to end the video here and start another one.